small n. Now you see, take the reciprocal. This inequality will reverse. 1 by small n is less than or equal to 1 by capital N. And this is less than epsilon. We have selected capital N satisfying this same condition for small n. 1 by capital N is less than epsilon. So then we have 1 by n is less than or equal to 1 by capital N is less than epsilon. And this shows that this statement holds, second holds. Therefore, 2 holds, or means 2 satisfies. And hence if 2 holds, 1 holds. 2 and 1 are the same. So therefore 1 holds. And thus 1 holds means the limit of 1 by n is 0, or limit of the sequence is 0. And but for that, what is capital N? Now you see, we have selected capital N. Here the choice of capital N is important to show the limit. There we have to find capital N. So this is important according to definition. So capital N we have selected such that 1 by n is less than epsilon. Now 1 by n is less than epsilon means capital N will be greater than, take the reciprocal, 1 by epsilon. Capital N is greater than 1 by epsilon, then the statement 1 holds. Then 1 is true, or we can say 1 holds, satisfies, and therefore for this choice of n we obtain the condition 1 is true, and this shows that limit of Sn is L, or that means limit of 1 by n is 0. So this proves limit n tends to infinity of 1 by n is equal to 0. So this is the first example we have shown, limit of the sequence is 0. Now what is the meaning here is epsilon is greater than 0. So we can consider, suppose epsilon is, if epsilon is say any positive integer and that is small, any real number, not positive integer, any real number which is small and positive. So epsilon is 0.1, then what that will stand? This will imply n. That means this implies mod of Sn 1 by n minus 0 is less than 0.1, and this will happen for n greater than or equal to n. So this will imply 1 by n is less than 0.1, n greater than or equal to n. So we can select capital N as satisfying this condition. If we take 1 by capital N is less than 0.1, then this implies, take the reciprocal, n is greater than 1 by 0.1, or that means this implies n is greater than 10. 1 upon 1 by 10, that is 10. n is greater than 10, and thus if you consider the term n greater than 10, then the distance between 1 by n and 0 will be less than 0.1. That is obvious because we have this sequence as 1, 1 by 2, 1 by 4, etc. And if you consider n is 10, 1 by 10, that is 0.1. So thereafter the sequence, the term will be 1 by 11, etc. and all will be less than 0.1. So this is illustration of, that means this n depends on epsilon. If you consider epsilon as 0.1, we have to select n greater than 10. Now if you select epsilon as say till smaller, that is epsilon is equal to 0.01, then how will be the what will be the choice of capital N? So this will imply 1 by n is less than 0.01, and we have to select n satisfying this condition. And if you take the reciprocal, this will be greater than, the reciprocal of this is 100. So that means after 100 terms, the 1 by n term will be within distance 0.01 from 0. So that is, it will become closer. If you increase the values of n, then this will be closer and closer to 0. That is the meaning of the definition. When n is sufficiently large, that is n is greater than or equal to a fixed number, then the distance between Sn and L is less than epsilon. If this is smaller, this will be increased. as you see. For point 1 it is 10. After 10 onwards terms, because what is actually the 10th term of this sequence, 1 by 10, which is equal to point 1. After 10th term it is 1 by 11, 1 by 12. All these will be less than point 1. So that is satisfied. 1 by n will be less than point 1. And similarly, if it is epsilon is 0.01 after 100 terms, actually 1 by 100 is 0.01 and 1 by 101 will be less than this, and that satisfies this condition. So this is the meaning of limit of a sequence. So this is about the first example. We have shown this sequence has limit 0. Now we shall consider the second simple example, that is the sequence Sn given by. We have to understand the definition and how to apply the definition. So we know limit of 1 by n is 0 as n tends to infinity, but actually we have to according to the definition, means according to this procedure. And here we shall consider Sn as a fixed number. Sn is equal to 1, has the limit 1. Actually this is Sn is 1 means the sequence is, so Sn n takes value 1 to infinity, or that is 1, n takes value 1 to infinity, and means each term of the sequence, here actually Sn is 1 or n is equal to 1, 2, 3, etc. Means every term of the sequence is fixed 1, or it is a constant sequence. So the terms of the sequence will be 1, 1. First term is 1, second term is 1, S1 is 1, S2 is 1, etc. It is fixed, and so on. So obviously its limit will be 1. It will approach to 1 only. So this is the meaning of the example. A constant sequence has the term as the limit. And here what is Sn? Sn is 1. And what is L? L is also 1. So therefore, according to definition, see, given epsilon greater than 0, we have to find n belongs to I such that. So this definition is, this words, this statement is to be remembered. Given epsilon greater than 0, we have to find n belongs to I such that mod of Sn minus L is less than epsilon, n greater than or equal to n, or n greater than or equal to 1. And this is simply here, both are equal to 1. So 1 minus 1 is less than epsilon, n greater than or equal to n, or here it is 0, 0 less than epsilon, n greater than or equal to n. And this is obvious because the choice of epsilon is greater than 0, means 0 is less than epsilon. So this is true for every n. Whatever this, actually this does not depend on n, and therefore it is true for n. Capital N is equal to first term only, that's 1. So this is true for all n. All n is equal to 1, 2, 3, etc. Since by choice epsilon is, since epsilon is greater than 0, therefore 0 is less than epsilon, and we take n is equal to 1, n greater than or equal to 1, and this shows that limit of Sn is equal to 1. So that proves the result. Limit of this sequence is 1. Now third example we may have as, so here limit n tends to infinity of 1 is equal to 1. Limit of constant is the same. And now we consider the next example, which is the sequence Sn given by Sn is equal to n. N takes value 1, 2, 3, etc. That is obvious. N takes value 1, 2, 3, etc. Has or does not have a limit. There is no limit for this sequence, or limit does not exist for this sequence. So there are some sequences we have seen, it has a limit. Now this is an example of a sequence which don't have a limit. See actually what is the sequence terms. This given sequence is Sn. Yes. Sn, n takes value 1 to infinity, or that is n takes value 1 to infinity. And what will be the terms? It is n. S1 is 1, S2 is 2, and so on. 1, 2, 3, etc. So these are the terms of this sequence. And as we see, as n increases, the number increases, and therefore this will not approach any fixed number. Or we should not say infinity is the limit of this sequence. Infinity, because infinity is not a fixed number, and limit of a sequence, if it exists, it must be a unique number. So therefore this sequence has no limit, or limit does not exist for this sequence. We suppose on the contrary, suppose there is a limit. L is the limit of the sequence. Sn. L is the limit of this sequence. And if L is the limit of this sequence, then we must find capital N, satisfying the condition of the definition. So therefore, for given epsilon greater than 0, or for any epsilon, you can say, epsilon can be taken at our choice. Epsilon may be, as we have seen earlier, the condition is it is positive real number. Maybe 0.1, maybe 0.2, maybe 1, 2, 3, etc. For any epsilon greater than 0, there exists, or there is. N belongs to I, means natural number, positive integer. N positive integer such that mod of, every time we are writing the same condition of the definition, mod of Sn minus L is less than epsilon for n greater than or equal to capital N. Now put the values of Sn and L. What is Sn here? It is n. And L we have considered as the same. L is the limit. L belongs to R of the sequence less than epsilon, n greater than or equal to n. So n minus, now here we shall consider epsilon is equal to 1. Take epsilon as 1. Because epsilon is any greater than 0, positive real number. And therefore we take epsilon as 1. At our choice, take epsilon is equal to 1. So what this gives, n minus L is less than 1, n greater than or equal to n. Now what the inequality suggests? So this will be, this number lies between plus 1 and minus 1. Mod of x minus mod of x less than a means this implies minus a less than x less than a. So according to this, what we can write is minus 1 is less than n minus L is less than 1. N greater than or equal to n. And now add L throughout. So therefore what we will get is adding L, it is L minus 1 is less than, add L, this remains n, less than L plus 1, n greater than or equal to n. And what is the meaning of this? This says that after n is greater than or equal to n, all the natural numbers lie between L minus 1 and L plus 1. So is it possible? So L is a fixed number, it is a limit, means L is a fixed number. And if you suppose this is L, then what is L plus 1? L plus 1 will be 1 unit distance on right side, and L minus 1 will be 1 unit distance on left side. So this is L plus 1 and L minus 1. Suppose L is say 10, then this will mean this is 10, this is 9, and this is 11. And what this says, for every integer n greater than or equal to capital N, this integer lie between L minus 1 and L plus 1. Now if capital N is 100, then this will mean that every integer greater than or equal to 100 will lie between L minus 1 and L plus 1. How many integers are there which are greater than or equal to 100? There are infinitely many integers, and they will not lie within this finite length. That means this is a contradiction. So 101, 102 and so on, 1000 etc. they will not lie between these two, whatever L may be, fixed number, and therefore this is a contradiction. This shows that, or this means all integers or positive integers greater than or equal to n lie between L minus 1 and L plus 1. This is a contradiction because infinite number of integers will not lie within a finite range. You verify this. Why this is a contradiction? We have considered just as L as any number and N as any number. So greater than or equal to capital N means there are infinitely many numbers, and this gives a contradiction. This is a contradiction, and therefore our assumption is wrong. The sequence has no limit. What we have assumed is L is the limit of the sequence, and this is on the contrary result. So therefore Sn has no limit. Sn has no limit, or limit does not exist. This sequence has no limit, and this proves the result. So this sequence has no limit. It is because the numbers are not approaching towards terms of the sequence are not approaching towards a fixed number. It is becoming bigger and bigger. Now, but that does not mean that a sequence whose terms are becoming bigger and bigger or smaller and smaller has no limit. We will consider one more example. The sequence Sn, where Sn is equal to minus 1 raised to n takes value 1, 2, 3, etc. does not have a limit. Or this sequence has no limit. So this we shall consider as in the earlier case. Now see, we apply only the definition. So that is in analysis definitions are important, and we have to understand and how to use the definition. And consider now the solution. Here Sn the sequence is minus 1 to the power n takes value 1 to infinity, and you see the power of 1, positive power of minus 1 is either minus 1 or plus 1 according as the power is even, odd or even. So it is 1, minus 1 raised to 1 is minus 1, minus 1 raised to 2 is 1. So the terms becomes alternate, plus 1, minus 1, etc. And what is the limit of this sequence? So we have to show this sequence does not have a limit. There is no limit. We can't say the limit of this sequence is 1 because all the terms are not approaching towards 1. Similarly, we can't say the limit of this sequence as minus 1 because all the terms are not approaching towards minus 1. And thus the terms are oscillating finitely, but the terms are not becoming bigger and bigger, but they are oscillating between minus 1 and 1, and this has no limit. Here also we suppose on the contrary, Sn has limit L. Has a limit L. And if it has a limit L, then it must satisfy the definition. So therefore, given epsilon greater than 0, there is n belongs to I such that, according to the definition, such that Sn minus L is less than epsilon. n greater than or equal to n. So this is the condition here. This is the definition. Every time we are writing this statement. And now what is the Sn minus 1 raised to n? See. And what L we are assuming a limit actually. So here we are not proving a certain limit, but we are assuming limit L. So L is the same and is less than epsilon, n greater than or equal to n. Now we will consider this as our first statement. So this must be satisfied. But you see there is no fixed value of minus 1 raised to n. It depends on n is even or odd. Now in case n is even, so what is minus 1 raised to n? If n is even, we know that minus 1 square is 1, minus 1 raised to 4 is 1, etc. So therefore, if n is even, it gives the result. Then 1 says that. 1 says that or 1 gives. Mod of 1 minus L is less than epsilon. Or before that, we should consider a fixed value of epsilon. So take epsilon is equal to half. Epsilon, given epsilon or given any epsilon, given or any value. So we can take epsilon as half, 1, 10, etc., 0.1, etc. So take epsilon is half. So what this will imply? Therefore, this will imply minus 1 raised to n minus L is less than half. N small n greater than or equal to capital. And we suppose this as 2. And now we refer this. So if n is even, then 2 says that. So what will 2 say? This is 1. If it is even, it is 1. 1 minus L is less than half. And n greater than or equal to n. And we suppose this as 3. And if n is odd, then 2 says yes. If n is odd, then minus 1 raised to odd number is minus 1. Minus 1 minus L is less than half. N greater than or equal to n. Say 4. Now we have to observe 3 and 4. What is meaning of the statement 3 and 4? See, geometrically, what is the meaning of mod of x minus a? Mod of x minus a will stand for distance between x and a. And if it is less than delta. Now we will have, say, this is a. And this will actually imply a minus delta is less than x is less than a plus delta. And thus, what is the delta distance on this side is a plus delta, and delta distance on left side is a minus delta. So this will mean x lies within this interval. X lies within this interval. So this is the implication of absolute value. And what this means, 1 minus L means distance between L and 1 is less than half. And what this means, this also means distance between minus 1 and L is less than half. So both will mean that L L is within distance less than half from 1 and minus 1. So 3 and 4, the statements. 3 and 4 says that or implies that or means that L is less than half unit distance from 1 and minus 1. So only you consider this part. L is half unit distance, less than half unit distance from 1 and minus 1. So is it possible? Both must be satisfied. Now see, if we consider 1 and minus 1 here, it will be 0. Suppose 1 is here and minus 1. Now if L is less than half unit distance from half unit distance from 1, then L must lie, so this is half, L must lie like here, then it will be less than within distance from 1, less than half unit distance from 1. But in that case, if L is in this interval, L will be far away from -1 or will not be less than half unit distance from -1. So this is actually a contradiction. Or if L is within half unit distance from -1, then L will be in this interval. And then L will not be less than half unit distance from 1. So this is a contradiction because the distance between -1 and 1 is actually 2. So therefore this is a contradiction. No L will satisfy these both the conditions, that is half unit distance, less than half unit distance from 1 as well as half unit distance from -1. So this is a contradiction and thus the sequence has no limit. So you remember this part also. The sequence -1 to the power n has no limit or does not have a limit. So thus we have considered few examples and we have checked the limits according to the definition. Thank you. Next part we will continue further.